Dear calculus students, here is another applied question for you. The question reads, the volume V of a sphere of radius r changes over time t. A. At what rate is the volume changing if the radius increases at 10 inches per minute when the radius is 9 inches? B. At what rate is the radius changing if the volume increases at 4 cubic inches per minute when the radius is 5 inches? All right, let's get started. First of all, you need to know the formula for calculating the volume of a sphere. The volume V of a sphere is given as what? 4 over 3 pi r cubed. So remember, we are talking about change. Whenever you hear this change, it means derivative. So the first question here is talking about the change in volume. And remember that this volume V is a function of t, time, right? So we can simply differentiate both sides with respect to t. So dV over dt, which is the rate of change of the volume, is equal to, you know that these three will drop down to multiply. So we have 3 multiplied by 4 divided by 3, then pi r, you know, you're going to reduce the power by 1, so it becomes 2. Remember to multiply by what? dr over dt, because we are differentiating with respect to t. But suppose we are differentiating with respect to r, you don't have to multiply by dr over dr, because dr over dr is equal to 1. Okay, let us further break it apart, because this 3 will cancel this 3. Finally, dv over dt is equal to 4 pi r squared dr over dt. So first question here, we are asked to find the rate of change of the volume. So this is the rate of change of the volume, right? When the radius is 9 inches, so we are going to substitute r equal to 9. And this is another rate of change, but for what? The radius, because you can see that here, the radius is increasing at the rate of 6 inches per minute. So we substitute 6 and 9. So this is equal to 4 pi r, which is 9 squared, dr over dt is 6, right? Yeah, it's 6. So we have 6 here. We have 9 squared, which is 81. Then you take 81, you multiply it by 6. That will give us 486. 486 multiplied by 4 will give us 1944. So this is 1944 pi. So this is the rate at which the volume is changing when the radius is 9, and the radius is also changing at the rate of 6 inches per minute. Now let us take the second question. Remember that this is A part, then the B part. At what rate is the radius changing? This time around, we are looking for the rate at which the radius is changing, which is this one. So let us make it the subject first. So the B part, to make it the subject, we can divide both sides by 4 pi r squared. Therefore, dr over dt is equal to the left hand side, we have dv over dt divided by 4 pi r squared. So now let us bring the data. You can see that the rate at which the volume is changing is what? 4 cubic inches. So this is equal to 4 divided by 4 pi. What about the radius? The radius is 5 inches at that point. So we have 5 squared. You see that this 4 will cancel this 4. To the bottom, we only have pi multiplied by 5 squared, and 5 squared is 25. Hence, this is equal to 1 divided by 25 pi. This is the rate at which the radius is changing over a specific time. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.